So I'd love to introduce Elif. Elif was born and raised in Berlin, Germany, where she studied mechanical and biomedical engineering. Her professional career has been diverse, ranging from working in R&D in large corporations to joining an early stage startup where they were attracted by the sense of responsibility and the opportunity to shape the company's trajectory. Elif has also worked in government and management consulting. She's very much drawn to creating meaningful impact and roles that allow them to play a pivotal role. Recently, Elif made the move to Australia and says, "I am loving it here. Besides my professional pursuits, I am very outdoorsy. I love the feeling of the sun on my skin, even though I do my very best to block it SPF 50 all day, every day." So Elif, over to you.
Thank you very much. I'll just share my screen real quick, which can, as we all know, sometimes be a bit challenging. Yeah, it's also challenging today. Oh, I've got it. Too many screens. All right. Do you all see it? Does it look okay? Perfect.
Yep, looks
okay.
great.
Great. So thank you for having me today and for giving me the opportunity to speak about what we do at the IT Hub. And also thank you for the introduction. My name is Elif Küçüktaş. Yeah, and I was born and raised, as she said, in Berlin, Germany, and yeah, moved over to Australia just recently. And I joined the IT Hub, I think 3 months ago, so pretty fresh. And yeah, today I'll be speaking about what we do at the IT Hub, what it is, and also I'll present the projects that we are currently working on. Obviously not all of them, but a few, so you can have an idea from, there are also different levels of, let's say, sophistication. So you get a good overview of our work. Now, because I'm an engineer, I really like my numbers, and I would also like to start with one, actually two. So 1 in 6 people worldwide experience significant disability. And here in Australia, it's 1 in 2 people who rely on assistive technology in their daily lives, which is quite a big number for such a, let's say, yeah, tiny market in terms of AT, assistive technologies. And I'd like to finish the introduction with a quote by Jeff Parody: "With the right technology, we will have a world where I can't becomes I can, but that technology you can only get if someone makes it," which is exactly why we're here today and why we do what we do. Let me start with who even are we, the IT Hub? What do we do? Where are we located? And let me start with the localization. We are at the UNSW. We're part of the UNSW and the Graduate School of Biomedical Engineering, to be a bit more precise. The AT Hub piloted in 2019 with a project called Biomechanics of Physical Rehabilitation. So that is too kind of fresh. And also, I don't know how you feel, but I feel like the COVID years kind of disappeared from the calendar, so it's even fresher. And how we work is people reach out to us. It could be people with disabilities, their carers, family, friends, clinicians, whoever, with an idea for a product, or if, you know, that is in demand at the moment. And if it fits with our criteria, for instance, low tech, high impact, we take over the project and offer it to students, and they can do it either in a context of a course or a thesis. But it doesn't stop there. We have like highly engaged students. It's really remarkable what they have been doing so far. They started several student associations. One I will explain a bit further on another slide, but there's also been a collaboration with a university in Uganda, where they basically try to develop an upper limb orthosis. I think this is how you pronounce it. Forgive me if I butchered it. That you can make out of readily available materials, because some people don't have access to such products, so they can basically build it themselves with off-the-shelf products. what is our vision and mission? So the AT Hub is a community where we collaborate and innovate to develop life-changing assistive technology. We work with our end users from the beginning of the design process, transforming them from clients into co-creators. That is very important to us. We don't just go and have a chat and then it's done in terms of contact. They're continuously engaged in the development process because they are the experts. They are the ones who use it and they have all the experience, and they're engaged throughout the whole process from beginning to end, and also give feedback regularly. And our mission, we are an inclusive community that harnesses the expertise of people with disability, students and experts to co-create personalized solutions to vastly improve the daily lives of differently abled people, helping them participate fully in society. Now, I mentioned that we have like highly engaged students, and this is one of the work that they have been doing, one of the outputs. And as you can see, the students on the picture, they all have some teddy on their hand that has like fancy LEDs lighting up. And this is really honestly very exciting, and I'm amazed how they've done it, because they just came up with the idea a few months ago and they've been doing several of those workshops. They even have like a different product now that they offer as a toy. What they do is, because toys are very important for people in the development process, it's support the growth of motor, cognitive, linguistic, and social interaction skills. And just a side note, adults don't play enough as well. Like, we should also play a bit more. It's very important for development. But sometimes toys can be a bit tricky for children who have limited mobility. And that's why they thought, why not get a toy that's like easily available in a store? They just purchase it and then adjust it in a way that people with disabilities or children with disabilities can engage as well. What they did with that toy is there's like a switch, a button that you press, and then it lights it up. The LEDs light up. And again, it's the concept of having education, like you educate while it's also delivering value for people in need. The toy workshop is offered to, I think, anyone. It's mainly students who, I think so far it's been only students. I'm not too sure, but since it's a UNSW workshop, I guess it reaches students mainly. So you can sign up for that, and then you soldier and you learn technical skills, how to do that. They teach you it on the go, and then at the end of the day, they have toys that they can then give to children in need. Now to some of the projects that we have been working on recently. This is a rather simple, low-tech, but still high impact project that I have been working on. So we have a lifestyle clinic on campus, and they know about us because we've been engaged with them previously. And they reached out asking if we could help them with a leg press. So imagine being short and using the leg press. If you don't really have long legs, it's hard to get a lot of movement out of the leg press, right? So you're already like, your legs, I'm exaggerating, but your legs are almost stretched out when you rest your foot on the platform. So you don't get enough movement. And they asked if we could, help them with a simple solution with that. And I ordered EVA hard foam, and that was perfect because it's very lightweight, but still very resistant. So it hardly gives in if you step on it. It's really stable, which is very helpful and handy for this type of project. And since the staff will pop it on and off multiple times per day, and I know that they are using it as well, and they're very happy with it, which I'm very happy about. It needs to be lightweight because, and also simple to put on and off. And I basically cut the foam in shape and printed 3D handles, like 3D printed handles that I just glued on top, and that was like project sorted, done, and immediately creating value for them. They also reached out regarding another project. Basically, it's the same device, but they said that some people have leg length difference, and then they usually take like some sort of disc that's flying around, pop them under their foot, but it's not very stable, and they asked if we can help them out with that as well. And so I ordered 2 more of those mats in 1 and 2 centimeter thickness. And I just put some strips on it, and ordered some magnets that I sewed onto the strips, which was very fiddly, by the way, but I'm glad it's done now and it's working well, because apparently the glue wasn't sufficient enough. It was gliding, but that's just a side note. And now they can use the thinner mats on top of the big one, or by itself as well. Because of the magnets, it doesn't, it's very flexible in terms of where you put it. And they mentioned that the clients that they have sometimes have shaky legs. So they asked us if we could increase the grip on the mats. And I just got some grip spray, went generously over it, and done and dusted. Now, this is a project that I'm currently working on, and disclaimer, it's not fully functioning at the moment, but it's almost there. And I also broke a part. I'll show you in a second. I'm not sure if you can, I think you can see me, right? Yeah, beautiful. Okay, so an OT reached out to us asking if we could help one of her patients. She apparently likes to play Xbox, but she can't use her left hand the way she would like to because of cerebral palsy. She has limited movement in her left hand. And then we went and met up with her. And she also brought her controller that she's currently using, and she showed us how she's using it at the moment. And it was basically like, if you can see me in the camera here, it was basically like if she needed to use the other buttons, she went like, usually you play like this, right? But she went like this and then like that, which is not a pleasant gaming experience. It's, you know, you want to have fun when you game, but it's been a bit of frustrating of an experience for her because of her limited mobility. And yeah, when we asked her what she would prefer, she said that she would prefer to use her right hand only. And we immediately thought, okay, this is going to be quite the project, because if you look at the size of the buttons, if you had to place them all on the right side, you can't just do that. You would have to shrink them or decrease the size, maybe, you know, come up with different buttons. We would have to cut a controller open initially to understand how is it even wired. We would have to rewire it, develop a whole new design, and 3D print everything. And yeah, that was going to be a longer one. But we always do a bit of a market analysis when we have people reaching out to us for a new project. And then I saw that you can 3D print something to basically pop on top, and that was available online and for free as well, which was great. And we do have really a lot of tools and devices on campus. So we have like several 3D printers. So 3D printing is not an issue on our end, which is great because she couldn't have done that herself. They obviously, you know, as a private person, you don't have a 3D printer. And yeah, and then I just 3D printed it, and yeah, I'll show you real quick how this one's working. So you can see that in the middle, the buttons are obviously empty, and they are the buttons that you don't really use very often. You know, when you start the game or something, or you need to adjust something, you go there. And then this bit that broke, I need to fix the joint, but basically it's kind of like an elongated button. You can see it on the photo as well, kind of, you know, it goes like this. So she can, when she has her hand rested here, she can just press the buttons here instead of basically here. And at the back here, you have 4 buttons. So you have 2 here and 2 here. And since she can only use that side with her left hand, so she can, of course, reach those ones. And you see the part here, it's connected to the buttons on the other side. So she can basically push those buttons in order to press them. And my favorite part, I'm really surprised at how well it works as well, is the toggle. So you can use the toggle by moving the whole controller, and you do it by either resting it, there's some kind of like a part that has some increased grip, I'd say. And you could either rest it on a table or wherever, or as you can see on the photo on the right hand side, with the blue band, you can put it on your leg. So if you game, sometimes you're like in a really comfortable position like this, have your legs up, and basically I'll show you. So when you rest it and you move the controller, you move the toggle, and it works quite smoothly as well. Like I'll show you here. That's pretty neat, if you ask me. So yeah, I'll finish off that project and hand it over to her soon as well. And yeah, finally, I'd like to show you present one of the projects that the students are currently working on, which I find really exciting as well. And I think this has a lot of potential. They named the device Ultravision. And Ultravision allows people with vision and hearing impairment to perceive and connect with the world around them. Now, how does this work? You see this device on the bottom right side that has an ultrasonic sensor for detecting objects, and you can adjust with the toggle. Of course, you can turn it off. You can adjust it to 1, 2, or 3 meters where it detects objects. And then it's basically, it vibrates when it detects something, so there's something in front of you, and maybe you want to be a bit more careful. And the co-creator in that particular case, I think he's wearing hats and he wants it to put on top of his head or underneath. I'm not too sure, but basically he asked for a headband. But technically, you could wear it as a necklace or on your belt as well. It doesn't really matter. And I'll show you how it looks on the inside real quick. You have, electrical components, several of those. The first one, the sensor, you can purchase online. It's really affordable as well. I Googled, it's like $10 or something. Obviously the circuit, and then you have a rechargeable battery, and the rest, the housing is 3D printed. And yeah, as I mentioned, they're still working on it, so I can't 100% tell you how well everything works. Initially, they had like a presentation recently where I asked, if the ultrasonic sensor actually, works as you would expect, or if there's glass, how does that work? And apparently it works quite well, and even glass it doesn't cause an issue, which is, I find really fascinating and amazing. Like, yeah, I'm really excited about this project, but there are really a lot of projects going on at the moment. I think like 7 that are, really exciting. I hope that I didn't ignore anyone's questions, but we have reached the end of my presentation. So thank you very much again. And I'm, happy to answer your questions if you have any.
Hi, Elif. I assume that ultrasonic sensor is actually 2 sensors, and then you have something internal that vibrates. Can they identify which one's which, so the user can find the boundary of something?
I'm not sure. I know that the ultrasonic sensor is different to I forgot which other, but basically it has it receives and so it sends the signal and receives it at the same time. And then I think with the circuit, it sends to another tiny thing. I'll show you. You see the little bit here. I'm assuming that this is what's actually causing the vibration. But to be fair, I'm not 100% sure. But I'm guessing that this is, So basically the signal goes in, and then I'm not an electrical engineer, so I can't 100% tell you what exactly is happening on that circuit, but I would guess that from the sensor, the signal goes, so it sends, it receives, and then the signal goes into the circuit, and then if this is actually the part that causes a vibration, that it vibrates then.
What? Sorry, can I ask a question? One thing, have you had the opportunity to visit the Northmead workshops?
Sorry?
Have you had, it's Fred Thompson here, have you had the opportunity to visit the Northmead workshops and see the facilities we've got there?
No, not yet.
I
Is that
really
an
think
invite?
it would be of interest, because we may have some complementary stuff that you could actually use here. We've got the CNC routers, and we have got a number of 3D printers as well.
That's really exciting. I'm sure Maeve can connect us afterwards.
Absolutely. There have been some conversations about a partnership, like a University of TAD type partnership, and I believe Stacey did pass on a client that we actually couldn't find a solution for, so perhaps for your team to work on over the course of a number of weeks.
Mm-hmm. I'm sure most of the communication has been done with the associate professor, Lauren Carr, who's basically started all this. Yeah.
But it does look like a fantastic resource that we could tap into as well, if we could, because well, I'm an engineer, as you'll hear, but to have that resource to a number of engineers would be excellent as well.
Yeah.
Fred, we might just allow for one more question if anybody has one, because we have 2 more speakers and we just want to keep to time today. Anybody else? No worries. Well, Elif, thank you so much for coming along today and presenting about the University of New South Wales. The ultrasonic sensor just reminds me of a project that NRL and Telstra are working on specifically for people with vision impairment, so that they can experience the games. I'll actually send the article around to everyone to have a look at afterwards, but it's pretty cool. Yeah. Okay, well, thank you very much. No worries at all. So we might move on then to Fred. So Fred, if you want to share your screen when you get a chance. Fred is a chartered professional mechanical engineer for more than 50 years. He has extensive hands-on design experience as well as engineering management. He's been a volunteer at TAD and its successors for about 22 years. He's designed and made dozens of projects for TAD/Freedom Solutions with both timber and metal, including recently reworking the bike U-frame designs to suit current bike range. So Fred, over to you.
Thank you, Maeve. Before I really get into this, I'd just like to recognise the contribution of Mike Muir, whom I see sitting with Katrina there in the office. The steps are, these are for Helena, who is, I'll just take a step down here, who lives in Kemps Creek, which is an outer suburb of Sydney. She's now around 12 years old, I think. She's small stature and needs a platform to access the standard bench height activities at both our school and at home. Now, Helena's OT has considered these issues in quite a bit of depth and came up with sketches of proposed dimensions, which I have used, and in fact they found to be quite appropriate. The steps have to be easily moved by Helena from one place to another, The OT suggested spring-loaded casters, like similar to those used in library platforms. And I just mentioned that due to the distance from the volunteers' home, it was all really done remotely by email and email communication. Now, the original proposal, to get things off the ground, I created a model. This was done in SolidWorks, a model quickly produced to illustrate the concept, basically, and with the intention that it would be refined later. But one difference that I did make was to propose a wheelbarrow type arrangement. A number of people asked me when they saw the device I finally came up with why I didn't use that system. And the reason was it was in fact rejected by the client as being too heavy for Helena to move. Now, all the construction here is based on 12mm thick plywood, and that included the handrails. At this point in time, we'll come to something later, but it has doubled up 12mm. We move on now to my proposal to accommodate this spring-loaded idea. Individual spring-loaded casters are much more complex than appear at first glance, and suitable types are just not available commercially. One of the reasons is that they've got to be custom tuned to whatever weight of platform that they're on, and they tend not to be very stable because anyone standing on it, it will go down in one corner initially. So I came up with a plan to where we mount all the casters on a separate platform. And the idea was to counterbalance the mass of the steps so that whenever anyone stands on it, fairly lightweight, there will be simultaneous contact in all 4 feet, or near enough anyway. At this stage, I had proposed to use a tension spring for to lift the platform. Also, a detailed proposal was put together at this point, where there was an extensive description of how all this worked. And that, in turn, I believe, was accepted by the clients. Now I'm really going to the nearer to the end of the project at the beginning here, but then I'll take you through the steps that went to produce these steps. But the initial orders and the manufacturing sequence, the initial order was for 2 sets of steps. One at 1200 wide for school use and one 900 wide for home use. The 1200 wide was completed first, and it was found satisfactory, but too large for all the applications at the school. The 900 was completed next for home. It was similar, but slightly different. I tried a slightly different approach. And the school subsequently ordered 2 additional set of steps, a 750 wide and a 600 wide. And I'm going to show you the end result at this stage. So these are the finished steps, starting on the left with the largest, taking you through 900, 750 and 600. So I'll explain how we got to that stage from that initial proposal. The design, there was several iterations in the design. The design was created on SolidWorks, a 3D modeling and drafting package. And an application like this is essential for this kind of project. 2D drawings are optional, but generally they're recommended so we know what's going on. I've been using this package for both professional and voluntary purposes for about 20 years now, so it's really well and truly mature technology. Now, the core of the design is based on the cutting of plywood panels on the Northmead CNC router. And I would say now at my stage in volunteering for Freedom Solutions that probably it would now be rather too large a job for me if I was to make them from scratch by, cutting them with the tools in my workshop. A 2D engineering drawing of each step was produced, of each step assembly was produced to guide the assembly part. Now, DXF files were produced for each panel, and these files were then translated by Mike Muir, whom I mentioned earlier, to a forum suitable for the CNC router. Now, this is to give a little bit of an idea of how I approach. We tend to improvise a fair bit in Freedom Solutions, and the way the caster carrying platform worked is a parallelogram action, and the way which requires a double pivot, and in fact 4 double pivots. And the way I achieved this double pivot action was to weld together a pair of hinges, so that that produces the double pivot very inexpensively and simply. And you can see this is a section through one of the sets of steps, and you can see how the mechanism here works. And later I'll show you, I'll do a share screen of the actual SolidWorks model, and I can show you it operating. Interestingly, and this might be of interest for other volunteers, there were some hinge issues which didn't appear until I made the last one, strangely enough. And that is when you bolt or screw down a hinge onto a flat surface like that. In the case of the latter set of steps, the hinge was, there was friction between this pivot, the pivot, and the, that stiffened up the hinge and made it unacceptably stiff. So a couple of things had to be done. I had to put some spacers under the hinges to bring them off the surface to give clearance. Ultimately, I would probably get a groove machined just under the 2 or 3 places where the hinges contact the surface. I would just move on to the final hardware that I used here. I decided and then not to go with the plywood handrails. There are some issues with these. Rounding them over isn't the best, although we've used plywood handrails in a number of cases. But anyway, I decided to use a tube, 1-inch tube, which is what stainless steel tube comes in, 25.4. And instead of the coil spring, I've used gas struts instead of the coil springs. And these have a more or less constant force. They were purchased from Bunnings. There is a limited range. So there's a 325 centers one, which is 150 Newton, and a 100 Newton one, 185 centers. In the case of the 1200 steps, we use 250 Newton ones, which I then actually had to counter it was too high a load, so I had to counter it a bit with a coil spring. And as I mentioned, inexpensive. So here's a picture of the hardware that I made up. It also shows one of the shorter gas struts. mostly made from 25 by 25 3 angle. I'm slightly embarrassed about my shaky TIG welding. And indeed, the picture shows a redundant bracket, which is to accommodate the shorter gas strut when needed. Now, coming to the manufacturer, Mike Muir was a major contributor to this. He interpreted all the requirements, which, based on the limited amount of drawings I produced, was quite tricky at times. He set up the CNC machine, obviously, to nest the panels as best it could be done, and actually cut the panels in accordance with the DXF files. The CNC cut panels, for those who are not aware of what can be done, they are really incredibly accurate. To design these panels, though, it's necessary to be aware of certain constraints of the tooling. And some time ago, Mike published a guide about that very subject. If Mike wants, he could throw in a few comments here, but there are quite a number of issues that you have to be aware of. Inside corners, for example, need to be either post-treated or treated in another way during the manufacturing of the panel. The construction is based on dado joints throughout. I've used 4 millimeters deep, which is a third of the depth of the panel, and I think that is a good compromise personally. And all these dados sort of interlock, so the steps, in fact, would stand up themselves without any adhesives. But so, in fact, it makes it a little tricky to put it together. There's no nails or pins or screws used at all in this construction. And in fact, I constructed it upside down using the top platform as the base for it. It was all glued together with PVA adhesive, and the brackets and hinges were attached with M6 button head screws. I had to drill out the hinges actually to accommodate them. And finally, the photos again, as you can see, the idea was countering the weight of these steps and to raise the whole assembly by about 10 to 15 millimeters from the floor level so that they could be rolled around. There was quite a bit of hysteresis. It took very little weight, maybe about 5 kilograms, and that varied a bit. One of the issues that made it a little bit tricky was juggling the different weights and the different capacities of those gas struts. The gas struts, by the way, I should have mentioned also, they have a lot of features which made life easier in that they have ball ends, they have a fixed maximum length, and they have, which means that you can set that height, and they have a constant force. So most of them, it's around about 5 kilograms, but there is quite a bit of hysteresis in the sense that you push it down, they don't immediately rise up in some cases, depending on the extra, just how much extra we've built in to counter the weight of the steps. So really that concludes this part of my presentation, but I will show you, if I can, the 3D model. So if anybody got any questions at this point, feel free to ask, because I can indeed demonstrate and probably show you exactly how it works. What I'll do is I'll make transparent one side of the step so you can see the action here. This was the longer gas strut, and it's set diagonally. And the way it works is to, as you can see, this goes down to the fixed maximum length of the gas strut. Someone steps on there, it tucks itself in, and everything moves together. And as I say, I did mention that I tried an alternative, but I found the hinges not only were they a simple solution, but they were also the most positive, and gave constraint in the lateral directions as well, so that everything did move. It was quite freely and in a controlled manner. So there you go. Any questions?
Well explained.
Well explained, Fred. I just have a question, not that I can ask any real technical questions. It looks like a lot of work and thought to make it from scratch like that. Was there nothing commercially that you could modify that would suit the purpose, rather than like having to make everything from scratch?
I'm sorry, I'm not quite hearing you there.
Oh.
He said, was there anything commercially available that you could modify that would save you as much time that you put into designing something from scratch?
No, I did quite a bit of exploration of you know, the internet to search for anything like that. Obviously, if you go to Bunnings, for example, you'll find that they have a number of steps of different design. They do, in fact, have over center parallelogram type steps where the wheels are mounted similar to this, and it's a kind of over center device where there's a big lever, and obviously it has to be done with people with some strength ability to pull this lever over and lift the steps. And there are spring-loaded steps, but as far as I can determine, all the spring-loaded individual casters are all custom made by the manufacturer of whatever the steps are to suit the weight of the particular design. So I could have it would have been even more work, I guess. I could have designed and built individual spring-loaded casters, but I found this wasn't too much work. In fact, it was given that the panels were pre-cut, putting all this together, it still took a bit of time. They obviously have to be finished and glued together and so on. But because of the accuracy of the cutting of the plywood, it goes together really well. And Mike and I have had a bit of discussion about this, but we do add a little extra. I put in this particular project 0.5 millimeter extra onto the width of the rebates, so that the plywood goes into the slots without too much trouble.
It's quite impressive. Thank you.
Thanks, Katrina. Thanks, Fred. Mark Matthews Frederick said, great idea and final solution, Fred. And Ralph said, never cease to be amazed by the why am I can literally getting tongue-tied over a word. Of our volunteers.
One thing about the introduction I feel to suggest was, of course, you would have gathered from the accent that I don't hail from Australia either. I come from Scotland originally, but I've been here for a very long time. So it's obviously I like the place by now.
Thank you, Fred. Are there any final questions before we move on to our next presenters? Okie. Well, Fred, thank you so much. Wonderful presentation as always. I know you presented at the AGM and volunteer celebration last year as well. So thank you for taking the time to present again. I'll move across to George and Marika now. So Marika, feel free to share your screen if you'd like. So I'll introduce them now while you're doing that. So George has been a volunteer with Freedom Solutions Australia for the last 11 years. George is a keen runner, having run the City to Surf numerous times and has won Senior Volunteer of the Year in 2018. From our system, I can see George has worked on over 24 projects so far, but I'm sure that it's quite larger than that. Notably, George has designed and adapted the joystick controller car, saving one family over $14,000 compared to a commercially available non-modified option. So that's George. And Marika, who is the Senior Project Coordinator based in New South Wales, has been a part of our organisation for just over 7 years. Her expertise lies in overseeing the entire life cycle of unique solution projects within New South Wales and regional Victoria. Marika recently completed a Certificate 3 in Individual Support and Disability and was previously a product manager at Invacare, a manufacturer and distributor of medical products and services. So thank you very much, George and Marika, and we'll pass across to you both.
Thanks, Maeve. So I'll just talk a bit about the client and introduce his diagnosis, and then George will talk about the solution that was made. So this client was a quadruple amputee. He's a 57-year-old man. He was admitted to hospital with a staph infection, which ended up causing sepsis. He underwent multiple surgeries during a year-long hospital admission, and as a result of the infection, he underwent amputation of his 4 limbs. So it was bilateral below knee and left below elbow and right thumb and 4th digit amputation. So he came to us because he wanted to ride a bike again and enjoy that with his children. He attended a Freedom Wheels bike clinic where he trialled a recumbent. So he has prosthetic legs for mobility, as you can see from the image. The limitations were his right knee extension contracture, and the maximum knee flexion was about 65 degrees. So it was very clear a unique solution would be required for pedalling, transfers, brakes, and steering. So a quote was supplied for recumbent with pedal assist mid-drive motor. There's been several delays along the way, but we're very close to finalising the solution. Next slide are some images of the recumbent with the modifications made, which I'll get George to talk you through. Go, George. Oh, you're on mute there. Yeah.
Okay, thanks, Marika. One of the, in a way, good things about this project was the fact that the client could explain exactly when we were trying things, what he needed and what didn't work and what did work. The first thing we found is he doesn't have any a separate thumb on his right hand. Of course, he has no left hand at all. So he can't squeeze anything. So if you look down the bottom 2 there with that blue handle, for example, that's a rotary knob that controls the gearing in the rear wheel, in the hub. And normally, normal users just use a finger and thumb to turn it, but it needed things like a handle like that to turn it. And you can see just above that, a vertical piece of stainless steel that's been added to the handle, because the first thing you need to do to get on a recumbent bike is you need to put the brakes on. And the normal handbrake with a locking thing has a little pin that he couldn't work. And you can see just above the blue handle, both cases, or just below it on the left one, a round aluminium piece. And what that is a piece of 25mm aluminium machined up to fit in the handbrake handle as a latch. And he finds he can use his left arm on the stainless steel part of the handle and just his hand to push the right button in. So that locks the bike up. So now he can position himself on the bike. And as soon as he pulls the handle back again, the pin pops out and the bike's free to move. The next thing you'll see if you look at the right top one is that his heels wouldn't stay in normal heel cups. He needs the ability to get on and off by himself. So he doesn't want anybody else to help him. He wants to be able to do it himself. He doesn't want to wear cleats. He wants to be able to wear normal jogging type shoes that he can just get off his trike and walk. So cleats are out. But he can manage a big Velcro strap across the top there. We built just a bit of aluminium and to make two raised parts on the foot cups. The next thing was, because of his limited knee flexion, we got short cranks for both sides of the crank. The normal cranks were too long. We got shorter ones, which are a commercially available part, and put them on and then positioned the foot cups. They were too low on one side initially, and we trialed it with him and he said, let's move this up. So we moved it up 60mm and that worked. You can see also in the center upper run, the steering arms to help steer this recumbent bike has all got extra rubber foam tubing around it. So you can use his sort of forearms to steer it. But it looked pretty promising. His finger on his right hand can work the little controller for the electric assist. So that seems to work quite well. And the nature of the electric assist is you've got to be pedaling to get any assistance. And he can manage that quite well, provided we have the short cranks and suitably positioned. So I think we're pretty well there, but it's been a bit of trial and error to try and get the right positions for him. I mean, the basic trike is a normal recumbent bike modified with a mid-drive electric motor. I mean, it's called a mid-drive because it normally goes in the center of a normal bike, but of course it's right up the front on a recumbent.
Lovely. Thanks very much, George and Marika, for sharing that presentation with us. I'll open the floor now to any questions that anybody has, but I'll read a comment from Ralph, which was aimed to Fred. It was once said that the Greeks invented everything, but I'm beginning to doubt that the Scots must have had some input. So, any questions?
You might be interested in the Scots claim to have invented everything, but one of the lesser known things that were invented was copper wire, and that came about with two Scotsmen fighting over a penny. And with the recumbent bikes, just a question there, the steering is on the front wheels, isn't it? The two front wheels? Correct. Right.
So that the handbrake works both front wheels. They've got drum brakes on them, and the handbrake has a cable to each front wheel. So putting the one handbrake on locks both front wheels up for both stopping and, of course, to enable him to get on and off.
Okay.
George, I just wanted to ask with those foot cups, because I know when getting people on the bikes, how do they stay up? Because they tend to drop down with their weight. Is he able to, like, you can't really use a leveler, can you, for that? So how does he?
You can't really on those. He seems to be able to manage it quite well. I mean, I think the thing is the the big Velcro strap that holds his shoe in once he's got his foot in the position, he can sort of grab that with a combination of arms, and that I think helps it stay up. And because it's mounted so far forward, most of these cups normally are the centre points here in the pedal to the back.
Yeah.
Well, he's more like that, so
Right.
it's
better
more balanced than it is normally.
Mhm. Well, that's good. Yeah. So he kind of puts one in at a time.
He puts one in at a time, yes. Yes, he gets himself over the bike, sits down, and then puts one foot in, pulls the big Velcro over. But it's amazing. He is still trying to get funding for a left what's the word? Prosthetic, but one that's maneuverable.
Yeah.
Because he was saying a silly thing. He drives a car, but if he goes to a parking meter, he can't get the ticket out.
Oh my God.
You know, because he's got no free fingers. His hands like this. He has no opposed action at all. His hands like that.
Yeah,
His
right.
one and only hand.
Yeah, yeah. Oh,
So he's looking for some kind of mechanical left hand if he can to enable him to do a few more things.
yeah.
They're very expensive.
Yes, they are, and that's where he's fighting for funding.
Oh.
I went out with a guy one day who had a prosthetic arm, and the battery ran out after we were filming it. Battery ran out. It was something like $50,000 or $60,000
Oh my gosh.
for the arm. Yeah. So
Wow.
quite magical stuff.
Yeah.
Absolutely.
Like sci-fi.
Does anybody else have any more questions for George or Marika in relation to that client and project they worked on? I don't think we do. Okay.
One,
Oh, there was somebody else.
yeah, could I ask, is the project complete? I didn't quite get that. Has it actually been delivered?
It hasn't been delivered, but we're waiting. Actually, he lives down the south coast, so we have to get a time when he can come up and do the final fitting. But that's where we're at. It's just a coordination issue now.
Yeah, I think he had like some operations, or he had an operation in between, and his knee bend changed, and so they had to modify it again. There's just been little hitches along the way like that.
Okay, perfect. Well, thank you to all of our speakers for participating in today's Tech Talk. I'll just stop recording for now.